Alright, moving on. Question 5. Design a finite state automaton that recognizes the language of all strings, blah blah blah, where both ABC and CBA occurs as a substring. Oh man, that's really hard because I don't know which one comes first, the ABC or the CBA. So a good trick, if you're trying to design an FSA, sometimes you can split the language into two separate disjoint parts, both of which are easier to solve, and then you can just do the epsilon NFA trick where you like epsilon this one or epsilon that one. We know how to take the union of two languages, right? You draw a little thing, you epsilon up to this machine, or you epsilon down to this machine, and then you epsilon to a final state, right? That's how we if we have a machine for A and a machine for B, we can get a machine for A or B by doing this, right? So I'm going to break this into two parts. It's got the substring ABC, and then afterwards the substring CBA, or it's got the substring CBA and then ABC in a second, right? So I build machines for both of those, and then I can epsilon into both. I think that'll be easier to do. So here we go. So I'm going to epsilon up to the first machine. So this machine will check, has ABC somewhere inside, and then afterwards has CBA. So I guess read whatever junk you want, and then at some point you see an A, followed directly by a B, followed directly by a C, and then read some more junk, and then see a C, and then see a B, and then see an A, and go to a final state. Once you're in the final state, you stay there forever so you can read more junk. This is like a good attempt, but I can find a counterexample, A, B, C, B, A, which has got ABC, and it also has CBA because they share the C, and this is not going to work, right? Because I go epsilon A, B, C, and then I can't go forward on the B because I already gobbled up my C. So I guess I should also allow the option, if you read a C, you can skip straight over to here, right? There we go. A, B, C, B, A. And also if I have A, B, C and some junk and then C, B, A, it still works. A, B, C, read the junk, C, B, A. Okay, cool. And then we're halfway done. We're just going to do the same thing again for CBA first and then ABC afterwards. So epsilon transition, read whatever junk you want, C, B, A, read whatever junk you want, A, B, C, and then if they share the A, as in the string C, B, A, B, C, which has C, B, A, and A, B, C, but they share the A, you've got to be able to skip over. So C, B, A, all the way over the top. There we go. There's my finite state automaton. I guess by definition, each state has to have a name, so I'm just going to go through and give them really lazy, useless names. S5, S6, S7, S8, S9, S10, S11, S12. Cool, there we go. Ta-da. Is your finite state automaton deterministic or non-deterministic? Well, it's super duper non-deterministic because S3 has two C transitions. Well, alternatively, because this is an epsilon NFA. So maybe that's a better answer. So non-deterministic. As it has many epsilon transitions from S0.